Today, for the first time, we're going to see the combination of the wiring kind of stuff we've been talking about with programming these microcontroller boards, these Arduino boards. And we won't do anything like really interesting on its own. Grab a robot kit over there. But I think you'll start to see like what the power is of all this to combine input information and use that to determine what kind of output information, what kind of commands you want to do. So this week I gave you a couple of videos on transistors. Anybody have any questions about that? Did you feel like you sort of followed what the idea was of the transistor as a switch? We're not going to be talking about transistors as amplifiers. They do that, but for us, the main objective of the transistor is just these microcontroller boards. We can control what currents are sent. It's just we can't send big currents, and you need big currents in order to power big devices. And so instead, we're going to use the small currents that we program onto the Arduino board to control when larger currents flow. Grab a robot kit. We're going to start going through some combinations of wiring with programming. Okay, so the first thing we're going to do So today we're just going to do some Arduino examples. And the first one is we are going to get an LED to blink on and off at an interval that we choose. I'm going to do this one first because the current that you need to make a LED go on is small enough that we can do this directly from the output pins of the Arduino board. Okay, so the way we're going to do this is I'll draw a schematic first. We're going to program a pin. I guess for some reason, just randomly, I chose pin 8. You could do this with any pin. If you want to get crazy, choose a different pin. I'm not the boss of you. And then we're going to go through a resistor. That resistor is going to be 330 ohms. So that's the orange, black. Orange, brown stripes on the resistor. And then from there, we're going to go through the LED. The schematic for that is like, this is the schematic for a diode. That came up in the videos. And then to make it an LED, you just showed that this light energy is coming out of it. And then from there, we're going to go to the ground. So that's a schematic of the circuit that we're going to put together. So an example of what this might look like is, on your Arduino board over here, one of these pins is a ground. Here's our pin 8. Here's the breadboard. Everybody grab a robot kit. And so we're going to go, we're going to wire from pin 8 to the resistor. And then we're going to go through the LED. And then we're going to go from the LED to the ground. Okay, so a circuit like that will work. Let's use the red LED. That seems to be nice and bright at the currents that we're going to have here. And yeah, just take a second now and put this together. Remember that, so LED stands for light emitting diode. And a diode allows current to flow one direction but not the other direction. And so you have to know which direction an LED allows current to flow. Let me get mine out. And if you notice, if you get out that, we're doing the small red LEDs, not those big, huge ones. But if you get out an LED, you'll notice that one of the two wires is shorter and one is longer. The current is allowed to flow from the long through the LED to the short. Okay, so if you're setting up your circuit like this, the long side of your LED should be connected to the negative terminal of your resistor. And resistors don't on their own have positive and negative terminals. It's just the direction, you know, in this case, whichever terminal is connected to your pin 8 is the positive terminal, and that means the other one is negative. So if there was a 5-volt difference between pin 8 and the ground, that LED would be on. Okay, it would be shining bright red. Right now, there's no voltage difference between those two. But what we can do is we can program what the voltages are at these different pins. And so now we're going to open Arduino on the computers at the desktops there. I guess we'll just have to do this once per table. You can download the Arduino software. It doesn't take up much space or anything on your laptops at home. And then you can do all this on your own computer. I'm going to do it on the web because I'm not allowed to download stuff on my computer. When you open this programming environment, you see two things already set up. One is set up. And that's where we're going to define which pins we're going to be looking for values from. Those are our inputs. And which pins we want to set values to and say, okay, this one's 5 volts now, this one's 0 now. Those are the outputs, okay? Then after we've set that up, we've defined like the layout of the pins. Then we're going to go through a loop where it's just going to keep spinning through all the commands in this loop over and over again. And so that's really what this thing is going to do. Like for example, a dinosaur loop would be like look for animals, and then when you see an animal, eat it, and it just loops. That's what it does all day long. You know what I mean? And so that's what we're going to do here. Our loop basically is going to be, for this simplest program, it's going to say set pin 8 to be at 5 volts compared to the ground, and then wait some amount of time, let's say a couple seconds. Then set the voltage at pin 8 compared to the ground to be 0 and wait for a couple of seconds. And then it's just going to do that over and over again until we stop it. Okay? And the effect of that is going to be that this LED is going to blink. Well, computer programming, in most computer programming environments, you have to be ultra careful about how you enter stuff in. Using capitals when it's looking for lowercase, it's not going to really try very hard to figure out what you're trying to say. It's not like Microsoft Word or something. So you pretty much have to enter everything in correctly. But here is how we're going to do this. So in the setup, and you can see, by the way, these squiggly brackets, everything inside these 2 squiggly brackets, I'm gonna move my squiggly brackets down because that's just what I'm used to this looking like. But now everything inside those squiggly brackets is part of our setup, okay? And the only thing we're gonna do for now is we're gonna say, so if what we're trying to do is tell this pin 8 to go to 5 volts, then tell pin 8 to go to 0 volts, and so on, do we want to set pin 8 to be an input or an output? Output. Output, that's right. So we're telling it what to do, so it's an output, okay? And so the way you do that is through this function called pin mode. That's an Arduino function. And pin mode takes 2 arguments. First, you tell it what pin you're talking about. We want 8, or if instead of 8 you use 6 or 7 or something else, put in the pin that you want to define. And then in all uppercase, we want to put output. It's an output. We want to make that an output pin. And then finally, just programming thing. This is how the C programming environment works. Once your command is over, you tell it that's the end of your line by using a semicolon. Okay, like I didn't make the rules. We don't get to make the rules. Those are the rules. Okay. Notice that so if you typed in pin mode right, all that text should have turned green once you finished it. If you didn't, maybe you didn't use a capital M or something like that, but it. Okay too. Let me look. I've never seen it red. Okay, yes. Okay, yours is red, mine's green. And now that the only pin we care about, we could go through and do this for all the pins on the board, say this one's input, this one's output, but the only ones we're going to use right now is 8, so that's fine for us. Now we're going to go into the loop, and now we're going to tell it what to do. And so we're going to use 2 other Arduino functions. The first one is digital write. So it's lowercase digital and then capital W write. And if you type that in correctly, it'll change colors again. And the arguments for digital write are, first, what pin do you want to write to? And then second, do you want to write it to be, computer stuff is all 1s and 0s. So basically, do you want it to be 1 or do you want it to be 0? If you want it to be 1, that's equivalent to 5 volts compared to the ground, and type in high. Okay, and if we want it to be 0 volts compared to the ground, we'll type in low in capitals. That's the end of our command, so semicolon. And then we'll decide how long we want to keep this on. We could make it blink really fast, or we could, let's do, now we're going to choose how long to wait before we write it to 0. That's going to use the Arduino function delay. So let's go delay, and this is in milliseconds. So if we want, let's leave it on for 2 seconds. So that's 2,000 milliseconds. Semicolon. And then we'll do digital write again, but this time we want to program pin 8 to be low. And don't forget the semicolons. Anything like that, forget a semicolon or whatever, the whole thing won't run. And then I'll do a delay of 1 second this time, so delay 1,000. And that's going to be the end of our loop. So it enters the program. It says that pin 8 is an output. Then it enters the loop and does that forever, basically, as long as we have power running to this board. And so it says, put pin 8 to 5 volts, wait 2 seconds, put pin 8 to 0 volts, wait 1 second. It gets to the end of the loop, so it goes back up to the top and does it again. Okay, and so then 5 volts, 0 volts, 5 volts, 0 volts, it just does that. Anybody have any questions about that? You sort of follow the flow of that? I mean, like, why the syntax is this way, like, there are reasons for that, but that's not our concern. We just have to follow the rules of how you enter this stuff.
So I use always 5, or we can change it for some.
Yeah, so all we can do with these digital pins, these digital output pins, is say that it's 5 volts compared to the ground, or it's the same electric potential as the ground. That's all we can do. So that's digital means just 0 or 1, you know. So that's all we can do. Once you have this programmed, go up to sketch, I think. The word right above there. Sketch.
All here?
Yeah. And go verify, compile. And if there are no mistakes, you'll have to give it a place to store it. Give it some name, Blink LED or something. Blink 182. And click that, and it says that it's done. And so in that case, it worked fine. I think some red errors will pop up if it doesn't compile correctly, but yours worked fine. So let me know if you do that and there's an error. For the first time, we are drawing electricity out of this board. And these boards are sort of weak, sensitive. And so it's always good to be careful about how much current you're trying to pull out of these things. So what are the board and the pin limits? You should, from a single pin, you should keep the current below about 40 milliamps. Okay, and from all the pins that you're using together, keep the total below about 200 milliamps. Okay, so now we're going to combine the, what we're doing here, just in the sort of spirit of keeping, being careful as we do this stuff. We're gonna get out the multimeters and we're gonna test the current here that's going into this board. So the way we're gonna do that is, let me draw this and then you can go get the boards. Remember that if you're measuring the current, you have to make a break in the circuit and insert the multimeter in there. So I'm going to get rid of that wire, and I'm going to go like 8 to somewhere. And then I'm going to go this to the milliamps of the multimeter, yeah, thank you. And then here's the ground of the multimeter, the common, and I'm gonna go here. Okay, and what you should see is you can put it on 20 milliamps will work. But what you'll see is that the current is going to blink back and forth between something around 10 milliamps or something, and then 0 when it blinks off. Okay, so everybody just one per table, and you can just pass the multimeter around. But get out a multimeter and get out a red and a black lead over here, and just make sure that you're able to measure this. So right now we have a way to program very small currents, but currents that small aren't useful for very many things. Okay, now the next step is, instead of using this programmed current to power whatever device we want, we're going to use this programmed current to switch a transistor on and off. And that gives us a whole new level of power, of literal electric power to use. So here's what we're going to do. So now we're going to use the same idea, but pin 8 will switch a transistor. Okay, and we're going to run a motor through this. So now this motor, it's not like it's a high-powered motor, but it's these motors take a lot more power, a lot more current than you can draw from these pins. Okay, so now what we're going to do is this. We're going to go from pin 8, or whatever pin is programmed. We're going to go through a 1,000 ohm resistor. We're going to go through the tip 120 transistor that I talked about in the lectures last week. We're going to go through the motor there's the battery. Let's use a 9-volt battery. I'll get some of those out. So this is a schematic of what we're trying to do. And there's one thing missing that we still have to do. Do you remember what that is? If we're using a motor. So this was like what I gave you for the general device, yeah.
We need to diode off of that.
Exactly. We need to we need a diode that will allow current to flow from the negative to the positive, but not from the positive to the negative. Okay, so I'm going to put a diode across this. Like that. Okay. Yep. This is obviously, this schematic's more complicated. So going from this, yeah, that's it. Yep. So going from the schematic to the actual wiring is not as obvious on this one. But let's start thinking it through a little bit. We have the board. And here's our ground. And here's our pin 8. And from pin 8, we're going to go through a 1,000 ohm resistor. And then we're going to go through the transistor. So here's the transistor. Here's the tip 120 transistor. And remember the names of these are, this is the base, collector, and emitter. And we're going to go from the emitter to the ground. I'll go around here like that. And now this is going to power, so I'll draw the battery over here. Here's the positive and the negative. We want the negative to be connected to the ground. Let's see. So I'm going to connect that to this row here with the emitter and with the ground of the board. And the positive is going to go, so this whole thing is a breadboard. The positive is going to go through the motor. And so I'll draw the motor like this. And Then the negative of the motor is going to go through the collector. And then last, we need the diode that's going to go so this is the positive side of the battery. This is the negative terminal of the battery of the motor, I mean. And so we want this diode to go only from the negative toward the positive.
Which motors should
Good question.